Hey everyone, and welcome to Math Fundamentals, where we're going to be exploring some basic and maybe some more complicated concepts that I think are important in the world of mathematics. So today we're going to cover scientific notation, what it is, why it's worth exploring, multiplying and dividing them, and maybe some shortcuts that perhaps you haven't been taught in school or in class. So, whenever you're ready, let's get exploring. So, imagine the types of numbers that we're used to dealing with. Mostly hundreds, thousands, maybe even millions. But what happens when these numbers are really, really big or perhaps really, really small? What if you want to begin multiplying them or dividing these large numbers or really small numbers? Let's look at the example here. Notice that we have two really large numbers that we're multiplying. Then we have some division problems with really small numbers or large numbers. Yes, you can easily, show your work and multiply these out or divide them, but it's just going to take too much time. I mean, there's got to be some shortcut to that. That's what mathematics is about. And this is where scientific notation is really, really helpful. Let's look at this example here. Notice I have a really large number and a really small number. I can easily convert the first number into 1.54 times 10 to the power of 12. And I can convert the one on the bottom into 3.46 times 10 to the power of negative 6. Now I want you to notice a couple things here. Notice that we have a base of 10 for both of these numbers, and these exponents are different. The one on the top has an exponent of positive 12, and the one on the bottom has an exponent of negative 6. So how am I converting these into scientific notation? Let's take a look at this. There's a couple of rules when converting these numbers into scientific notation. The first rule should be to always locate your decimal. Now, when you have a whole number, their decimal is not going to be written, so the rule of thumb is that the decimal is going to be on the far right. For small numbers, as you can tell, the decimal is always going to be there. So that's the first rule. And then always make sure that there's only one digit, and that digit has to be between 1 and 9 to the left of the decimal. This will make a little more sense with time. The next rule is a nice little acronym that I like to use when moving these decimals that's going to determine what the exponent is going to be. The L stands for left, A, add, R, right, and S, subtract. So whenever you're moving your decimal to convert it into scientific notation, if you're moving it to the left, add. If you're moving it to the right, subtract. So let's look at some examples. Up above, I have that number 1,270,000. Now, there's no decimal, but again, the rule of thumb is the decimal needs to be on the far right. And I'm going to go ahead and move my decimal right in between the 1 and the 2. The reason being is because once I have that decimal there, remember, there's only one digit to the left of that decimal. So, starting from the original decimal, I'm going to move it 1, 2, 3, 4, 5, 6. Moved it 6 places, to the left or to the right. I moved it to the left. So, my number is now going to be 1.27 times 10 to the power of positive 6. Positive 6 because I moved it 6 units to the left, therefore I added to my exponent. Let's look at the next example. I have my decimal place already in line, and I need to move it in between the 6 and the 5, so that there's only one digit between 1 and 9 to the left of that decimal. Let's see how many times I move it. It's going to be 1, 2, 3, 4, 5, 6 again. But this time notice that I moved it to the right. So therefore my number is going to be 6.57 times 10 to the power of negative 6 because I subtracted. I moved right, so I'm going to subtract from my exponent. Let's do a couple more examples. I have these 5 numbers in standard form. Some are really, really small, some are a little larger. For the first one, I'm going to move my decimal 1, 2, 3, 4, 5, 6 units again, but this time I went to the right, so therefore I'm going to subtract. So my number is going to be 7.6 times 10 to the power of negative 6. The next one, I identified my decimal. 1, 2, 3, 4, 5. This time I moved it 5 times. So it should be 3.8. My decimal wasn't writing there. But anyway, 3.8 times 10 to the power of -5 because I moved to the right, therefore I'm going to subtract. Okay, let's see if you can locate the decimal for the third problem. Don't forget it's a whole number, so it should be all the way on the right, and I need to move it 1, 2, 3, 4, 5 units, but this time to the left. Therefore, I'm going to add to my exponent. 9.8 times 10 to the power of 5. Okay, number 4, decimal place is again at the very end. I'm going to move it 1, 2, 3, 4 units to the left, so I need to add 1.18 times 10 to the 4. Okay, last one. Decimal is already written for me. I need to move it 1, 2, only 3 units to the right, so I need to subtract 4.56 times 10 to the -3. It's that easy. Now this is super helpful again because we can convert these numbers into, I guess, condensing them so they look a little neater. And now when it comes to multiplying and dividing them, it's going to become so much easier. Let's see why that is. Let's focus on just multiplying scientific notation numbers. There's 2 rules here. Whenever we're multiplying, we're first going to multiply the numbers first. So for example, 9 times 5, that's going to be 45. And then I'm going to add the 2 exponents. I have a 3 and I have a 2. And when I add those together, that's going to be 5. So I have 45 times 10 to the power of 5. I love this answer because we think we're done. We have 45 times 10 to the power of 5. But notice that this is not written in scientific notation. This is a lot of times something that our teachers forget to mention. And when it comes time for the quiz or the test, we get things wrong. What we need to do is we need to fix this. Again, let's locate the decimal in that 45. It's going to be at the very end. And I need to move it 1 unit to the left. Okay? To the left because I need to have it to be 4.5. So now my answer is going to be 4.5, and keep in mind, times 10 to the power of, my exponent's going to change. It was originally 5, but because I moved it to the left, I need to add 1 to the exponent. It was originally 5, and now it's going to become 6. This is big, I'm telling you. Whenever you take a quiz or a test in class, some teachers fail to mention this. Maybe they'll briefly touch on it, and if you're not paying attention, ooh-wee, we're going to get this wrong. All right, let's try the next example. Again, multiply the 2 numbers together, 3.2 times 1.8, and that's 5.76 times 10 to the power of, add the exponents, 2 plus -4, that's going to be -2. And this is complete. Why? Because we only have 1 digit between 1 and 9 to the left of the decimal. The next problem, when I multiply 8 times 3.5, I get 28. I already know because my decimal is to the at the end of the 8. I need to move it, but we're going to fix that in a second. This is going to be times 10 to the power of 9. Again, notice that I added the exponents, 6 and 3. Now, my decimal is at the very end. I need to move it 1 unit to the left, so I need to add to my exponent. So my actual equation is going to be 2.8 times 10 to the 10 power. The last one, 3.25 times 4, that becomes 13 times, now I'm going to do 10 to the power of 9 plus -7, that's positive 2. All right, what do you think? Are we done? Or do we have to do one last thing to that 13? We definitely have to move it. Locate the decimal, move it 1 unit to the left, and of course this is going to become 1.3 times 10 to the power of, it was originally 2, but we moved the decimal 1 unit to the left, so we need to add 1 more, and that's going to be 3. Not bad. Again, multiply the 2 numbers together, add the exponents, and adjust. Let's try dividing scientific notation numbers. It's going to be pretty much the same rules as multiplying, but in this case, because we're dividing, we need to divide the two numbers together, and then instead of adding the exponents, we're going to go ahead and subtract the exponents. The first one is going to be 9 divided by 3, that's just 3, times 10 to the power of 7 minus 5, and that's 2. And we're done here. We didn't have to move the decimal. It's kind of nice. The next one, 6.4 divided by 8, that's going to be 0.8 times 10 to the power of 4 minus negative 6. This is tricky because we're doing 4 minus negative 6. Think about that. That should be 10. And you think you're done here, but notice that the decimal needs to be moved, this time to the right. We need to move it to the right once. So our answer is going to be 8 times 10 to the power of, normally we've been adding to the exponent, but in this case, because we moved it to the right, think of the acronym, LARS, we moved it to the right, so we're going to subtract. So this is going to be to the power of 9. If you look at the next problem, 2.8 divided by 7, that's 0.4. I already know I'm going to have to change that. Times 10 to the power of negative 6 minus negative 7. This one's tricky. Negative 6 minus negative 7. If we're not careful, we'll get this incorrect, and we have to know our integers. This is going to be positive 1. Of course, we're going to locate the decimal, move it 1 unit to the right, and so this is going to become 4 times 10 to the power of 0 because we subtracted from the exponent. Now, we can leave this answer like that because technically it's scientific notation, but hopefully we know what 10 to the power of 0 is. If we do know, we know it's 1, so technically we can say that our answer is 4. Both are going to be correct. If your teacher is picky, they're going to want you to write it as 4 times 10 to the power of 0. Up to them, make sure you ask them whenever you're covering this in class. Next, we have 1.21 times 10 to the power of 8 divided by 1.1 times 10 to the power of 5. Let's divide that 1.21 by 1.1, and you get a nice 1.1. Should have put that in red, I'm sorry. 1.1 times 10 to the power of 8 minus 5, so it's going to be 3. And we're in luck because we don't have to change anything there. Pretty simple. Again, if you're multiplying scientific notation, multiply the numbers, add the exponents. But if you're dividing, divide the numbers and subtract the exponents. And that's it for today, everyone. I hope you found this explanation helpful. Let me know what you'd like for me to cover next in the comments below. Feel free to subscribe. Feel free to follow me on Instagram at The Vegan Math Guy. Until next time, peace and love.